Good morning, student. I am Sikander sir, and today I come with a new topic. Okay, we will discuss uh, the magnetic fields. How we can find out the magnetic fields on the axis of a loop. Yes, on the axis of a loop. That is the magnetic field. Magnetic field. Okay, magnetic field at a point on the axis of a loop. Okay, this is the topics that we will discuss, but before it, those who have not subscribed, please subscribe my channel. Okay, and now we will discuss the magnetic fields at a point on the axis of the loop. Okay, loop means what? Whenever we make the circle, suppose that we have this circular forms like that. Okay, and now we take, suppose that P is a point, and here's the magnetic fields we can find out. Okay, why? Because whenever the current will flow through this, okay, loop, you can increase. This is the y axis. Here will be y dash, okay, and here will be z and z as this is the origins. Okay, and now you take, this is the elementary portion, that is the A and B. AB is the elementary portions, and this is the point C. This is the point C, and A is the radius. A is the radius, and distance of OP is equal to x. Distance of OP is equal to x. Is it clear? And now you can join these ones. This you can join here. So here will be, it will move like that, and if you will join here, so that will be like that. Is it clear? You can give, this is the, okay, y and y dash. You can increase these ones. This is the x. Okay, if you will assume this is the theta, so that will also theta, and here is theta, so this will be also theta. Okay, now you can assume here is C, so you will take C dash. Here is the A dash and B dash. This is the elementary portion, and this having DL, this having elementary length DL. So here will be what? DL dash. Here will be DL dash. Is it clear? Okay, very good. And now here will be DB. Okay, DB, and this will be DB dash, because this is the downwards. And the magnetic field you can find out. So you can join here, and here also you can. So suppose that M, and this is the L. Okay, and component also you can give. So this will be the dB cos theta, and here will be also dB cos theta. Okay, and here will be dB sin theta, and here will be dB sin theta. Okay, so components you can also write. Now you will find out the magnetic fields. How you will find out the magnetic fields? Due to this circular loop on the axis, already we have discussed the Biot-Savart's law. What is the Biot-Savart's law? According to Biot-Savart's law, we have dB equal to mu naught by 4 pi into I dl cross cap of r by distance, that is the r square. This you will take. Okay, very good. Now if you will take these ones, you know, if you can remove, here is the unit vectors, this is the unit vectors. Okay, you can remove this one vector, so it will be in magnitude. So, or you can write dB dash equal to mu naught by 4 pi into I dl by r squares. So we got the, okay, we got the dB, that means the magnetic fields for these elementary portions, but you will find out the magnetic field due to whole circular loops. Okay, now, or also you know that these the magnetic fields and both will equal, since dB mod of dB is equal to mod of dB dash. This you can write. Is it clear? Okay, very good. Now you will find out the totals. Therefore the magnetic field due to due to Hall circular loop. Okay, so find out, that is the B is equal to closed integrals dB, and you have dB. You can put this value, so you will write D is equal to closed integrals mu naught by 4 pi into IDL by R square. Can we write? Okay. If you will write these ones, and also you know that if you will integrate this one, then the component will also you will take here. Okay, so this is the component at the point P, you will find out. So here will also sine theta. Okay, sine theta, and now you write outsides. So B is equal to mu naught by 4 pi. What is the value of mu naught by 4 pi? Mu naught by 4 pi is equal to 10 to the power minus 7 Tesla meter per ampere. Okay, this is the constant value, already we have discussed. Is it clear? Okay, so you will write here I by R square sine theta, then you have dl, close integral dl, and B is equal to mu naught by 4 pi into I by R square sine theta into this value you have 2 pi r. Okay, 2 pi r. Can you write? Okay, very good. Now you put this value, and if you will put the value of these ones, then what will be the answers? Okay, you can write here. If you will take this circumference, but you know that this is in the form of the circulars, and you have assumed here C is the A, so you can substitute here at the place of R. What you will take? You can take A, no problems. Okay, now B is equal to, also you know that from triangles you see that COP, here is angle theta and this is the perpendicular. Sin theta from triangles CPO equal to, what you can write? Sin theta is equal to P by H. It means P, that means what? A by H you have. This is the, you can assume this is the, suppose that R. Okay, so R you can put. Therefore B is equal to, you can write mu naught by 4 pi into I by R square into A by R into 2 pi A. Now you can merge this one, so here will be B is equal to mu naught by 4 pi into 2 pi I A square. Okay, 2 pi I A square by RQ. Okay, and RQ you will find out this value. How you will find? Okay, since you know that R square is equal to A square plus X square. So R is equal to root under A square plus X square, and you can also write these ones. So here will be B equal to mu naught by 4 pi into 2 pi I A square divided by, at the place of R you will take A square plus X square root under, and here will be 3. Okay, now or you can write here, so B is equal to mu naught by 4 pi into 2 pi I A square divided by, and this you can write A square plus X square, and root you will take half, that is the 1 by 2 into 3. Okay, so this you can write, this will be the answers. Is it clear? Or you can manage these ones. So here will be B is equal to mu naught by 4 pi into 2 pi I A square divided by A square plus X square and power 3 by 2. So this is your final answer for one rotation. But suppose that there is the n turns. If it has n turns, okay, therefore B is equal to mu naught by 4 pi into 2 pi n I A square divided by A square plus X square and power 3 by 2. Okay, so this will be the correct answers. Okay, this will be the answers whenever the, okay, you will take for the circulars or for the loop. Okay, means we got the result magnetic field at a point on the axis of a loop. Okay students, so you should write these ones, and those who have not written, write fast, or you can take captures also. Okay, and still please like my this video, and at least in one group please share this video. Okay, thank you students for sharing. And now you can find out their special cases. What will be the special cases? A special cases, suppose that this P lie at here, then how you will find out? Here I am erasing here. Suppose that a special cases. Okay, first you will take when P will lies at O, origin. So what you will write here? You can write here, that means this distance x will 0. X will 0, now put this one, so here will be b equal to mu naught by 4 pi into 2 pi n I a square divided by x square at the, okay, a square at the place of x square here will be 0 square and power 3 by 2. So this 2 and this 2 will cancel out, and now you have b is equal to mu naught by 4 pi into 2 pi n I a square by a. This you can also remove. Okay, and another case you will take, this is your works, when p will, okay, or x will large distance, on that case what will be the answer? Second special cases you will find out and you will comment me what is the answer. Is it clear? Okay students, thank you.